check that.
Okay, it's recording. So I guess the first question I have is, have you guys looked at the APIs at all? What do you know and what do you not know?
I'm a blank slate. Know nothing.
Okay. So let me give you a little. Kyle, did you and Ben have anything you wanted to add?
We're also blank slates.
Okay. So the simplest. So I guess the simple thing is that all you're doing is making REST calls. So at some point in the last few weeks, you've probably made a REST call. So we're good there, I think. So let me give you a little bit of maybe overall background of how this kind of fits together, and then I'll show you the kind of the APIs and how that works. So I'm gonna kill my Slack. Nobody really needs to record that. Okay, so the car has a set of REST services, and it's not really the car. The way it works is the REST services reside at Tesla, and then you make a connection to the Tesla mothership, username, password. You get back a token, and then in that call you'll get the vehicle identification number, and then you make subsequent calls to the REST services, and then those calls go through the mothership and then down to the car, and then the car, of course, responds with things like location and anything that you're asking it for. So inevitably, what you have to do is you always have to ask for a token first, so you're authenticated. Once you're authenticated, then you can make subsequent calls to any of the REST APIs. And I do apologize because I'm sitting outside on a balcony, so there's some car noise here. So the easiest way so let's back up this one more step. So a year or so ago, I wrote a set of mock services that wrap all of the Tesla APIs, and I have since abandoned that because mine is old and not up to date, and there's a much better version that this gentleman named Tim Dorr has published, that's out on Apiary. So if you go to just a browser and do a search for Tim Dorr, Dorr, Tesla API, I think hopefully you can see that. The very first thing that'll come back, at least in all of my searches it's this piece right here. Am I sharing my screen? You guys can't see it. You guys see my screen now?
I can now, yes.
Okay. So if you type Tim Dorr Tesla API in a browser, you'll get this API or get this link here. It takes you to this docs timdor.apiary.io. So what that looks like is this here. And so if you've ever used Apiary, it's using the Blueprint framework. It gives you all of these things where there's authentication, there's vehicles, and there's vehicle commands. I'll try to make that big enough you guys can see it. So the first thing that you have to do always is authentication. So the way this works, and so I'm trying to get it on the screen. Can you guys see that all right? So when you're here, okay, you can see it fine? Okay, so when you go through authentication, you're basically going to make a call to this login endpoint, and it's going to return an access token back. But the way Apiary works is it sets up, a nice example of the way. If you go to the example, here are the things that it requires in the header: grant type, client ID, client secret, email, and password. And then it gives you all of these. So you have mock server here, you have production as well. So if you actually would change this to production and give it the right credentials, it would actually talk to the car. But if you leave it on mock server for the hackathon, that's just where most people are going to be most of the time. And then it gives you all of these examples of how to write the code. So if you want to do curl, there's a curl statement. If you want to do Perl, there's what Perl code would look like. Python, there's a whole bunch of them in here. But so for most of my testing, I just use curl. And so then the way this works is you basically, here are the parameters that you have to pass, the attributes. So if you switch over here to the console, you can do URI parameters or you can do headers. So I've already set up the headers. And so I just grabbed these right from the documentation for the API. The thing that most people miss is this client ID and client secret. If you look right here, they're available. So if you click on that, it'll take you to another page and give you the client ID and the client secret. And everybody uses exactly the same thing. So it's not like it's really that secret. But then along with those two things, the grant type of password, and then obviously this is a mock server, so it doesn't matter. Some fake password, some fake email. And then the nice part, what you can do is once you pass all those in, you can actually call that resource. And then it will give you, here was the header that you passed in, and here's the response that you get back. There's the header, and then there's the JSON body that comes back. So in this case, you're getting back this access token and this refresh token. All you really need is the access token.
Quick question.
Yep.
How did that, with the client ID was misspelled in your header?
Say again?
One of these has to use underscore.
Yeah, that's.
Yeah.
Remember that's. Yeah, I fixed it. Remember that this is a mock server, so it doesn't really validate the headers. What this allows you to do is to go ahead and get yourself set up so that when you do switch this to production, it'll actually make the real call. So this allows you to go through and kind of see, what it would look like.
So what's the point of having the correct client ID and secret then if it's not validating?
Well, so I guess in my mind, the way we did this, we've done this in the past with the hackathons. The downside of the Tesla API is that it gives you this token, and it's good for several hours. And even if you change the password, there's no way to flush the tokens. So as soon as somebody gets a valid token, they literally have access to the car for, I think it's like 4 hours. So what Matt and I did was everybody had to write their code and submit it to us for review, and it had to hit all the mock endpoints. So if you look, when you come down here and say this is the curl statement of what, and so here's actually, you've used Apiary before. You can call that from other code. It could be in your, doesn't have to be from this web page. If you can simulate all the calls through the mock services, because when you actually make the other calls, you'll get real JSON responses back. And then we review the code, and then at that point we let them have access to the car. And so, we give them the real username password. The client ID and the client secret have to be correct. If they're not, they'll never get authenticated. So the reason it needs to be correct is that, they don't have to change their code when they switch to production.
Okay.
Does that make sense?
Yeah, so over the course of the weekend, when would that be?
So the way Matt and I did it we did it in the last two hackathons that we were at. We made them use the mock services until they came, so the prizes come out, let's say on Sunday at 4 o'clock. We set up a window where people were allowed to come to the booth from 2 to 4 on Sunday, and we would review their code. If we determined it was safe, we would allow them to have the username password and they could test it out. Other than that, they had to hit the mock one all weekend.
Okay.
It was just too hard to control. Now, knowing Matt, if somebody comes to him like on Saturday morning at 2 a.m. and says, I want to connect to your car, he might just give him his username and password. You know that. So anyway, so let's keep going through this. So once you've made this auth call, you're going to get this JSON body back. At this point, what you really care about is this access token. Now, obviously, this is a mock server, so you're going to get ABC123. In a real service call, you're going to get something much more cryptic than that, but once you make the auth call, you need to store that access token. So, for example, I'm going to slide down here to the vehicles section, and so here's a list of vehicles. So if I look at this one, here's the description. Retrieve a list of all your owned vehicles. So in this case, Matt has one car. So what he would have to do, and so let's go to the example first. So in this case, you request vehicles, but you also have to pass this in the header, this authorization token into here, right? And that's where you would put in the header, that's where you would put the access token. So if you go back to the console, Here's the authorization. Obviously I'm typing it now, but in there you would pass this value inside the authorization header, and then when you make the call, you'll get back, there's the header, and then you'll get back a body that looks like this, and in this case it'll give you, there's the vehicle identification number, there's the VIN number of the car, and that's about, is it online? You'll get a little bit of information. Now that you've actually made the auth call and then made the vehicle call, you need this vehicle identification ID. Because if you keep going, now granted, every call after this is exactly the same. So if I come down to here and say wake up car, if I look at that, let's see. Yeah, here's the example. You have to pass in the header for the auth token, and you have to pass in, or in that piece you have to pass it, and then you also pass the vehicle ID as part of the REST URL. So if you go back to the console, here's where you'd pass ABC123, and then there's the vehicle ID, which would be on the parameter, on the URI, when you're building of course I'm building it graphically here, but then when you would make the call, it now knows that I'm authorized and this is the vehicle I'm talking about. So if you had more than one Tesla, you would actually be able to wake up one and not wake up the other. So all of these calls all require the auth token and the vehicle ID. So then there's what you would get back. You would get back the header, and then you would get this response of whether or not the result was true or not. You don't get a reason. You only get a reason on error. So if this was false, this value is false, you would get a reason here. Unfortunately, the mock server is very difficult to simulate a failure. So then, does that make sense?
Yeah, so there's only one response per endpoint then? There's no way that you're going to get different responses back?
Yeah, there's only one response. There's only one response per endpoint. That was it. That was the reason that I wrote the mock server that I created, because what I could do is I had like a successful response and an unsuccessful response. But the API has changed significantly since I wrote that, and I just haven't went back and actually updated it. So, now, a couple things too. There is a way. So all of these are the calls, things like unlock the door, honk the horn, flash the lights. All of the non-destructive ones are the ones that we typically ask people to call. Obviously, depending on what they're trying to do with their hack. In this API, they are not listed, but there are features that you can call to do summoning. So you can actually move the car programmatically. There is one feature that requires the key fob to be within a certain number of feet of the car. So that's one safety precaution that will keep people. The other thing is the API is fairly unstable. So to give you a little bit of background, it used to be that the summon, so you could summon the car forward and summon it backward, and then you could also summon it to park. The way it used to work was an HTTP request. So you would post the request to the endpoint. It would then drive for a number of seconds, and you would stop it yourself. So you'd push the button to start it, and you'd push the button on the app to stop it. So if you had the app on the phone, there was a situation where someone had started it and then dropped the phone and couldn't get back to it fast enough, and it drove into a parked car. So they now have changed it from being an HTTP request to a WebSocket request. I was able to get it to work, but the last hackathon, Matt and I basically came back and said anybody that is attempting to move the car will not be granted access to the API. So just for safety reasons, we don't want to have them move the car programmatically. So if they come back with a solution that they do want to move the car, they could maybe come back with a software solution. So, while it was simulating the move, we could print to the screen or something like that. But calling that API was something we deemed not, I guess, reasonable request. Any other questions?
Yeah, I had a quick question.
Whoever's talking, I can barely hear.
Oh, hey, this is Ben. I have a quick question about the target about error cases. Is that something they're just expected to lock out on in their own client libraries? Or how about stuff like 500 errors and 404s and stuff like that?
Yeah, you got a lot of background noise behind you. I can't hear a word you're saying.
I'm just going to type it in. How about that?
That's fine.
What have I changed? All right.
Yes, I think so. That's the way I would handle it, actually. Because the mock server doesn't, you can't tell the mock server to return you an error status. So now if you make a real production call, obviously you'll get a real response. But from the mock server, what you can do, if you wanted to, you could, I guess, fork this blueprint and write your own inside of Apiary, but that may be more work than they're really willing to go through. That answer your question? Okay. He gave us a thumbs up textually. All right, any other questions? Got to be more than just one.
So what at one point in the weekend, like when do they pick? I'm assuming in the first 4 hour section is when they're going to know whether they're going to be using this API, correct?
Well, you would think.
Or do they know coming in, or do they
No.
change throughout?
They
or
change
what's
throughout.
the process?
Yeah, there will be people that show up and know exactly what they want to do the moment they get to the hackathon. There'll be other ones that show up without even a team, and they'll wander around and find people that they're interested in working with, and they'll form a team and then decide what they're going to work on. Obviously, the longer they wait, the harder it's going to be to complete something. But I mean, most people kind of wander around, I'd say, the first 4 to 6 hours and figure out what they're doing. There's going to be some signage that Diane Kazal put together to have people, be able to go and look at the video that I put together and this API and that kind of stuff. But I would guess if you've never attended a hackathon, you'll find that the last, 6 hours will be the most hectic of the whole thing, because they'll have a great idea but not really know how to get it together, and they'll be stressing out and running fast to get that complete.
Okay.
What else? Did anybody join late and miss the first part of it?
I think I missed a little bit of the beginning.
Okay. What was the first thing you heard?
I think when I came in, it was which endpoint? I was discussing like the client IDs and the client password and like invalidating how you couldn't invalidate a token or something like that.
Yeah, okay, so you caught it pretty early. Yeah, so I can.
Yeah.
Yeah. I'm recording this. I'm going to send it out so everybody can rewatch the beginning if they want. But I mean, the high level.
Okay, that's fine.
Yeah, but let me give the high level. The high level is that, I mean, it's a set of REST services that exist at, I keep calling it the mothership, but at Tesla, and you don't actually communicate directly with the car. You make REST calls that authenticate you. It returns you a token, and then all subsequent calls from that point on, you have to have the vehicle ID and the token in order to be able to do something with the car. All requests go to the mothership, and then the mothership communicates to the car. So there are times where it's, when I say latent, I don't mean minutes, but there are seconds of delay, and there are times where certain things, if the car is not in a good state and the car doesn't respond fast enough, then you'll get an error code or error response back from the service. So a lot of them you have to just kind of understand that, if you don't get a response, you might want to try it again. It is, it's not 100% guaranteed.
So I know you've had like the whole Alexa and Tesla thing. Is there example code that's available or presented or anything like that? Or do you guys have examples where you've used this API at the code level
So I
that people can see?
Right. So I can share the the repositories on GitHub. They're all public for the stuff that I wrote for Alexa. Um, the interesting part of that is that it's all using the Alexa skills. So some of that makes the code a little more. I mean, Kevin, you've done the Alexa skills. They're not as clean as you would like them to be. Most of that stuff was written using Go. So all the interfaces to the car are using Go, and then all of that gets wrapped up in a JavaScript wrapper so that it can live inside of um, the Lambda environment. But I can share those. I can actually post those either to the Slack channel, or I didn't add them to the video because most of the time when we get there, we try not to lead them down a path of what, because the vendors are not allowed to recommend what they're allowed to do. They're only allowed to provide them things that they can connect to. Or, if somebody
Okay.
shows up with a whole bunch of Amazon Echoes, they're allowed to say, take one of these and go build something, but they're not allowed to say, go build me this feature because, there's a kind of a conflict of interest there. So that's the reason I was leery about releasing that stuff, because I don't want them to head down a path by our recommendation as opposed to their own.
Yeah, if you could put it in the Slack channel, I'd be interested in seeing it though. Um, so what is the contest measured on?
So it's basically, so because Pillar is a sponsor, they will be able to grant a prize. So what each vendor does is they say, okay, who or what group has solved a problem that meets our criteria the best? So since Pillar is bringing the Tesla, obviously they're going to want to have some solution that involves the Tesla. There may be other companies there that have, and so each vendor will give a prize for their specific category. At least that's the way it normally works. Yep. Yeah, Michael Sabalskas put a message in there. That's what I was saying, Mike. That Apiary, you can actually, if you can write the blueprint in a way that you can set it up to return error messages or error statuses, but this one does not. So if you would fork it and write your own or extend this one, you could solve that problem. So and Mike also adds that there's a prefer header. For testing, you can say prefer and status. So what other questions do you guys have? Just maybe in general about the hackathon or the Tesla or the API, any of those things? Nobody? All right. One last chance. This is recording, so I'm gonna send it out and let everybody be able to watch it again if they want. I think it's pretty simple. I mean, it's just standard REST calls. Kevin, you got anything else? You're the one. I'm hearing your microphone.
No, that's it. I just appreciate you putting the time into putting this together for us.
Oh, no problem.
It's reassuring.
Yeah. So I will. So just so you guys know, I'm in California. I'll be there through Monday. I'll be I'll be on Slack or an instant message or something, telephone. You guys all have my phone number. If you get to the point where somebody can't figure out something, just call me. I'll help work through it. I can jump on the beam. I think they're taking the beam to the hackathon. So, okay, guys. If nobody else has any questions, I'm gonna end this and we'll send out the video and you guys can go have some fun at a hackathon.
Cool, thanks.
See you guys.